Hello. So yesterday we learned how to solve quadratic and polynomial expressions by factoring. Today we are going to be able to solve any type of quadratic equation, so even if it does not factor. So by the end of class, you should be able to solve a quadratic equation. But before we continue, I didn't post the homework answers last night until about 10:40 at night, so if you want to take a second and check your answers, you're more than welcome to. Just a reminder, this is a video, so anytime that you want to pause, rewind, replay, you are more than welcome to. All right. So solving quadratic equations. Algebraically, we have four different methods. Factoring, which we focused on last 2 days. Square root, completing the square, and quadratic formula. Factoring, taking the square root, and quadratic formula, we did the three of those last year quite a bit. Completing the square, we did a little bit last year, but I know that you definitely did it in Math 2. Again, we saw it in Math 3, and now we're going to get back to it again in pre-calc. So, square root principle. Whenever you can get the equation down to x squared equals a constant, then all you have to do is to solve is to take the square root of both sides. And when you do that, don't forget that x will end up equaling both positive and negative, the square root of your constant. So example 1. I can start by subtracting 3 on both sides. So we get negative 1/4 x squared equals negative 3. X squared equals positive 12 because you have to multiply both sides by negative 4, the reciprocal. So then we get x equals plus or minus the square root of 12. We will learn how to simplify radicals that are not perfect squares soon, but for today, if it's not a perfect square, we can just leave it. Number 2, I'm going to first add 50 over. So we get 2 times the quantity x minus 5 squared equals 50. Divide both sides by 2. So we get x minus 5, that quantity squared equals 25. And now we're going to take the square root of both sides. So we get x minus 5 equals plus or minus 5, because the square root of 25 is 5, and plus or minus because we physically drew in the square roots. So then we end up getting x equals 5 plus or minus 5, meaning x equals, ooh, what happened there? That's not an eraser. Okay, there we go. Meaning x equals 10 or 0. Because 5 plus 5 gave us 10, 5 minus 5 gives us 0. So completing the square is another method. This method will always work, but may take more time. We use this when the quadratic does not factor. Completing the square makes a quadratic solvable by the square root principle, because essentially you're creating a perfect square trinomial. So what we're going to do when we solve by completing the square, any constant, move over to the right side. So x squared plus 4x plus something is going to give me 3. Now, that something is going to be very important. So if you look at the example up above, my 4 is my b value. How I figure out what I need to add is I'm going to take b, so 4, divide it by 2, and then square it. So I'm going to take my middle term, my b, divide it by 2, and then square it, and that's what I'm going to add to both sides. So 4 divided by 2 is 2, 2 squared is 4, so 4 is what I'm going to add. And equations, the nice thing about them is they're balanced. As long as you add 4 to one side, as long as you add 4 to both sides, it's totally fine. Mistakes happen when we forget to balance our equation, when we forget to add that 4 to both sides, but adding it to both sides keeps it equal. So now, on the left side, I have a perfect square trinomial. This is going to factor to be the quantity x plus 2 squared. My right side's equal to 7. And if you don't believe me, we can always double check. I want two numbers that multiply to be 4 but add to be 4, and those numbers would be 2 plus 2, or 2 and 2, so that combines to give that quantity squared. So now we have a problem very similar to the one we just did, where we have a quantity squared equals 7, so now I can square root both sides. So I rip that squared, the square root square cancel each other out, so we're left with the x plus 2 equals plus or minus square root of 17. So we get x equals 2 plus minus square root of 7. I think I said 17, I meant 7. All right, so that's how we complete the square. So example 2 is another example. If you try and factor it, it's not going to factor. So let's solve this instead of the quadratic formula. Let's solve this by completing the square. So we have 4x squared minus 8x plus something is going to give me 7. Move that constant over to the other side. Now, when I'm looking at my left side, 4x squared and negative 8x have a common factor. You have to factor that out when we're completing the square. So now that I factored out that common factor of 4, I can now identify my b of negative 2. So I'm going to take negative 2, divide it by 2, square it. So negative 2 divided by 2 is 1. 1 squared is 1. So 1 is what I'm going to add. But think about it. I'm not actually adding 1 because I factored out a 4. What I'm really adding is 4. So whenever you factor out a common factor, before you add that value to the right side to keep your equation balanced, make sure you multiply it back by that GCF to keep it equal. So now on the left side, I have 4 times the quantity x minus 1 squared equals 11. And again, that's why we do this, so we can get that nice perfect square trinomial. So now I'm going to isolate the square, so divide both sides by 4. So we get the quantity x minus 1 squared equals 11 over 4. Square root both sides. So we get x minus 1 equals plus or minus the square root of 11 over 2, because we get the square root of 11 over 4, but then that becomes the square root of 11 over square root of 4, and square root of 4 is a perfect square, so we get plus or minus the square root of 11 over 2. Add that 2 over, so I get x equals 1 plus or minus the square root of 11 over 2. I do not have to actually add those, and I can't actually add those because that's square root of 11. So that's completing the square. And last but not least, the quadratic formula always works, but as always, it takes some time. So if a quadratic does not factor, we don't want to complete the square to solve. Our other method to solve is quadratic formula. So if I have my 2x squared minus 7x minus 13 equals 0, I can factor this by doing x equals the opposite of b, so positive 7, plus or minus square root of b squared, 49, minus 4 times a, which is 2, times c, which is negative 13, all over 2a. So then we get, oops, that's 49, 7 plus or minus. All right, there's my calculator. So we have, oh my goodness, 4 times 2 times 13 does not matter the negatives because double negatives will end up being a positive. So we end up getting 104 all over 4. So we get 7 plus or minus the square root of 153 all over 4. 153 is not a perfect square, so you would not be expected to simplify that as of now. And finally, our last example, before you can use quadratic formula, you have to have your equation equal to 0. So I'm going to add that negative, or add x squared over, so we get 9x squared plus 4x minus 16 equals 0. And now we can use quadratic formula. So we get x equals the opposite of b, so negative 4, plus or minus square root b squared, 16, minus 4 times a times c, so 4 times 9 times negative 16, all over 2a, so 2 times 9. So we get x equals negative 4 plus or minus the square root of, let's see, 16 minus 4 times 9 times negative 16 equals 592 all over 18, and double check that's not a perfect square. That is not a perfect square, so again, for today, we're going to leave our answers like that, 592. All right, so that is our lesson for today. Hopefully it was all review. Maybe a quick refresher in completing the square, but you have the rest of the period to work on your homework. Your homework is in your book. Assignment number 3, page 57. Remember, the online version of the book is on our Google Drive. If you cannot find it on Google Drive, if you just do a quick Google search of our book, the PDF will pop up, so you'll be able to find it. All right. Good luck, and I will see you all tomorrow.